Alright, good day everybody. Mastermind here again. Today I'm going to do something very, very important in mathematics today, a very important topic in calculus that makes a lot of students running from further maths. You tell a lot of students why they don't do further maths in secondary school, especially in countries, in African countries and Nigeria. It's because of one of the topics is because of calculus and this part of calculus, which is integration. Well, integration is not as bad as they say it is. So let's go get right into it. Now, integration simply means anti-derivative. That is basically the root. It's a process that does the inverse of what we do in differentiation. Now, in more advanced term, integration is a technique used in math that is used to determine the area of the curve. The area of the curve. We use to determine the area of the curve of a function. That is basically the whole idea of integration. We use it to determine the area of the curve of a function. Or that's one of the most commonly used application of integration. Now, integration is divided into two major parts. Integration is divided into two major parts. Like I like doing it. We have the indefinite integration, and we have the definite integration. Now, the general form of an indefinite integration is basically that when you integrate, your answer will be a function of x. That is, you have x, or it might not be as any variable as the answer of the integration. Generally, the common way of representing it is this. Now, integral of f of x dx is going to be equal to capital letter f of x plus c. Now, capital letter f of x represents the integration of the function, while the c represents some constant of integration, Now, when you integrate using indefinite integration, you must add this constant of integration. It's a rule in maths that you must add it. That shows that you have done indefinite integration. Now, for definite integration, the answer you get will be a real integer. That will be a real number that is no x. And generally, the common way you can rewrite it is the integral of a to b of f of x dx is simply equals to f of b minus f of a. Now, f of b is the value when the upper limit is inserted in the integrated function. While f of a is the value when the lower limit is inserted in the integrated function. And then, so that means that the v itself is called the upper limit, while the a there is called the lower limit. Now, one of the reasons why definite integration does not have some constant of integration is simple. Because if you integrate and you insert b, it's going to be f of b plus c, right? And then it's going to be, and this one is going to be f of a plus c. There's minus here. So the minus multiply that plus there gives you minus. So we have plus c here in f of b, and we have minus c here in the f of a. So minus c plus c minus c gives you 0. That's why we don't write it. So one thing you need to notice is that for definite integration, we don't write some constant of integration. That's because our answer is the true value of x. So now the next thing to go on to is the various techniques that we use in integration. These are the common techniques that is used in integration. Starting from the basics, in most of it you see it as direct integration, but me I like calling it power rule of integration because it looks like the power rule of differentiation. We have integration of trigonometric functions. We have integration of exponential functions. We have integration involving natural logarithm. We have integration by substitution. And there are two types here. We have U substitution method. That is basically, so it's similar to differentiation, but this one is for composite function majorly. And we have trigonometric substitution, which is radical functions. We have integration by parts. We have integration by long division. We also have integration by partial fraction decomposition. So these are all the techniques that we commonly use for the basics of integration. So in this video, we're talking about this one, direct integration or power rule of integration. Let's go right into direct integration or power rule of integration. Let me underline it. Now, generally, let me give you the general formula of direct integration. And this is it. Integral f raised power n dx is equals to xn plus 1 over n plus 1 plus c. Now, this is integration by power rule for indefinite integral. And what I mean indefinite integral, I'm putting constant c. So when you see constant c, you are doing indefinite integral. So this is the power rule of integration. Now, I have a slide that is the important formula that I put into a block bracket. Now, it's commonly used for variable raised to constants. When you have variables raised to constant. Let's take an example. If we have integral x raised to power 5 dx. Now, the first ideal thing to do is to compare it. This is integration. This is dx, So this is this. X here is x, n here is 5. So it means that our n here is equal to 5. So following this rule, it's going to be x, as we have here. Then n here is 5, so it's going to be 5 plus 1 over 5 plus 1 plus c. Now, what is 5 plus 1? 5 plus 1 is 6. So it's going to be x raised power 6 over 6 plus c. That's the integration of this. Now, commonly, I like telling students, beginners like, that is simply add 1 to the power and then divide by the new power. That is the rule. Add 1 to the power and divide by the new power. Let's take another example. Let's say we have this. We have integral x raised power 8 dx. So if we compare this to our standard, we have integration, we have dx, we also have dx. So we have x and x, it means n is equal to 8. So following the rule, it's going to be x into x power 8 plus 1 over 8 plus 1 plus c. What is 8 plus 1? That should be 9. So x raised power 9 over 9 plus c. Now, there's a check that you can use to see if you are right or not. Now, I said something that integration is the inverse of differentiation. So what it means that if you have integrated a function, to get that function back, you need to differentiate that function. Now, I will make a video on differentiation, but just take this from me that. So let's differentiate this answer here, and see if we will get back this function. So let's go. We have to check if you are correct. So we have d of dx of x raised power 9 over 9. Now, this is the same thing as d of dx of x raised power 9 times 1 over 9. Now, there's what we call constant multiple of differentiation. We also have integration, by the way. You can bring a constant outside a derivative and then integrate and differentiate. So this is the same thing as 1 over 9 d of dx of x raised to power 9. X raised to power 9. Now, the power rule of differentiation is power times coefficient, power minus 1. That is the power times the coefficient, then power minus 1. So it's going to be 1 over 9 into bracket. The power here is 9, so you multiply by the coefficient of x, which is 1. So it's going to be 9x, then you subtract 1 for the power. So 9 minus 1. Now, what is 9 all in brackets? This is equal to 1 over 9 into 9x to the power of 8. Now you can divide. 9 here will cancel 9 here. So x raised to the power 8 times 1 is equals to x raised to the power 8, which is what we had at the beginning here. So you can see that when we differentiate our answer of integration, you get back the original function. So let me give you some practice questions that you can also try. Feel free to write the answers in the comment section. Try this, some practice questions. See if you can integrate the integral minus 11x raised to the power 6 dx. We have a second one, B. We have integral 15x to 7 dx. And we have a third one, integral 32x raised to the power 8 dx. Feel free to send it to type the answers in a DM. So that's about it for this introduction to integration and power rule from Mastermind. So thank you for watching this video. I remain Mastermind of Mastermind Tutorial. Have a good day.